Hello everyone, so let's start our pulmonary section and continue with ventilation and the dead space. So it's a clear thing that ventilation, and if anyone hears about ventilation, it is replacement of stale or not fresh air with the fresh air. Similarly occurs in body. When a person inspires, he brings fresh air. When a person expires, he removes that stale or non-fresh air. The types of ventilations, there are two types of ventilation, pulmonary and alveolar. Sorry. So the pulmonary ventilation, it is the volume of air moving in and out of respiratory tract during quiet breathing. We have seen before in our other videos that tidal volume is the amount of air that is brought in and out during quiet breathing. So pulmonary ventilation comes out to be tidal volume multiplied by respiratory rate, which is 12 per minute. So 500 ml multiplied by 12, which gives out 6000 ml per minute. So that is pulmonary ventilation. And alveolar ventilation now. So the alveolar ventilation is amount of air utilized for gases exchange every minute. So we would be confused about what is difference between pulmonary and alveolar ventilation. So the pulmonary ventilation is the amount of air that comes in and out of the respiratory tract, lungs, while the alveolar ventilation is the amount of air which is utilized for gaseous exchange. Means tidal volume is the amount of air coming in and out of the respiratory tract and alveoli and all the lungs, but the all amount of that is not utilized for respiration. Some amount of air is not used for gaseous exchange, that is considered as dead space. So in alveolar ventilation, it is only the air which is utilized for the gaseous exchange, which comes out to be tidal volume minus dead space multiplied by respiratory rate. So 500 ml minus 150 ml. So we will be discussing about dead space in below here. So let's assume for a minute that it is 150 ml. Why 150 ml we will discuss here. So 500 minus 150, which gives us 4200. 500 minus 150 multiplied by 12, so that gives 4200 ml per minute. So that is the difference, that pulmonary ventilation is the whole amount of air, means that passes from nose to pharynx and comes through the alveoli ultimately, and the alveoli ventilation is the amount of air that is utilized. So as here you can see dead space. Dead space is a part of the respiratory tract where gaseous exchange does not take place. So where gaseous exchange does not take place, does it take place at the nose? No. Pharynx? No. So that all parts are considered is in anatomical dead space. Anatomical dead space, which from nose to pharynx, trachea, bronchi or terminal bronchioles, all those places are the tract for respiration. All those are pathways which brings the air, but there is no accommodation for they can't play a role in gaseous exchange. So they are anatomical dead space. Physiological dead space are like anatomical dead space plus 2 volumes. As we know that, as we discussed in the earlier videos, that there may be ventilation but not good perfusion. So because of that, the amount of air is wasted. Or there may be proper ventilation but not proper perfusion, so there is less amount of gaseous exchange taking place. Similarly here, that's that is the same example. In some respiratory disease, air in the alveoli not function because of dysfunction or destruction of alveolar membrane. Like alveolar membrane is it does not have gas proper cell structure, or it is dysfunctional because of air. Because of that, maybe there is proper blood flow from that area, but it cannot get air from that because of dysfunctional alveolar membrane. So that amount of air is waste, that is considered dead space, because from that area we cannot get gaseous what we need. So that is dead space. Similarly, air in the alveoli which do not receive adequate blood flow. Suppose in alveoli, it is proper alveoli, it receives proper amount of air, it is proper ventilated, well ventilated, but there is not enough blood flow flowing from that area. So would there be gaseous exchange? No. So that is another reason. which is which comes into under dead space. So what is the normal value of dead space? It is 150 ml. How can we get that 150 ml? It can how to measure that 150 ml? It is through single breath nitrogen washout method. This is the method. Let I explain you. Here you can see a graph on the screen. Along with that, I have drawn a diagram. So think of a person which is like normally sitting, and he is asked to have a normal breaths, and after that the person asked to have sudden inhalation, and we supply the person with pure oxygen. When a person here, the person is normally sitting doing nothing and having normal breath, then here person is asked to have proper inhalation, means with full capacity and pure oxygen. So this green one, it's oxygen. So when a person inhales, the oxygen comes into respiratory tract, and the air this air which is already present in the respiratory tract is pushed to further spaces. As you can see in the diagram, these spaces are filled, that is pushed due to the oxygen. Now it also fills dead spaces, means all the alveoli, most of the alveoli which are functioning at that time are filled with those air. Now this is inspiration. Now a person is asked to expire, and the person is connected with a nitrogen meter. When a person is asked to expire, the first in the graph you can see the first sometime during expiration. So when a person is asked to expire, he is connected with the nitrogen meter. As you can see, I have drawn N here. He is connected with the nitrogen meter. So the first portion of the expired air which comes out of the respiratory tract, all of course it consists of oxygen, because first when a expiration, this is the only amount of air that goes out. So in the nitrogen the nitrogen concentration wouldn't rise, because that would be consisting of oxygen. And when after some time there would be rise in the concentration of the nitrogen level. Here you can see there is rise in the concentration of nitrogen level. After a certain time, a plateau phase is reached. So from this we can draw a graph, and it is plotted, and we can get an idea that the area without nitrogen and area with nitrogen. So this area where without nitrogen, this is with nitrogen, and we can conclude that the area without nitrogen indicates dead space, means. So it is a little tricky thing, but let I explain you once again. Let me explain you. So as we know that there is amount of air that is normally present in the respiratory tract, and that air consists of mixture of all other gases also. And then we ask the person to inhale, and we give him pure amount of oxygen that won't be containing any other gases. So that amount of air that is added will obviously push the air present in the respiratory tract towards the other parts of the alveoli. Yep, you got that. And after that, when a person is asked to expire, during expiration, this air is first removed as it is present in the upper respiratory tract. So that won't show any changes in the nitrogen concentration. So that not change in the nitrogen concentration will not appear on the nitrogen meter. So that is the amount of air without nitrogen. After that, the air coming from the alveoli will also come and will also play a role in the concentration. So slowly there would be rise in the nitrogen concentration, which is later plotted on the graph by planimeter. So after some time there would be rise in concentration as all of the alveoli removes its air, and because of that we can get the increase in level of nitrogen concentration. So initially the amount of air which didn't have any nitrogen concentration is considered as dead space, because we can get an idea that amount of air didn't play a role in gaseous exchange, because that was present in the respiratory tract throughout the throughout breathing process. That didn't play a role. That just, we can get that idea from that. It's just as simple as that. Then comes to ventilation perfusion ratio. So ventilation perfusion ratio is alveolar ventilation, which is considered as VA, and blood flow or perfusion is considered as Q. So alveolar ventilation divided by blood flow, which is 4200 by 5000, which is amount of blood passing through there per minute, gives us 0.84. It is very important to know that, because if there are any underlying disease, we can get an idea from that. So that's all for today. Thank you guys. Don't forget to subscribe and hit that like button. Thank you.